In the vast silence beyond the orbit of Mars, something unfamiliar is moving through our solar system. It did not form here. It does not belong to the Sun. And yet, it is here. For only the third confirmed time in human history, astronomers have detected an object that arrived from another star system, an interstellar visitor now catalogued as 3I Atlas. At first glance, it appears unremarkable. A faint point of light, a small, fast-moving body cutting through space on a steep, unbound trajectory. If it were not for careful measurements, it might have passed unnoticed, blending into the countless objects that populate the night sky. But as days passed and observations accumulated, that initial simplicity began to fracture. Because 3I Atlas is behaving in ways that challenge not our imagination, but our models, equations, and expectations of how natural objects are supposed to behave. And that is why scientists are paying attention. Not because it is threatening Earth, not because it is confronting spacecraft, but because it is quietly revealing how limited our understanding still is when it comes to visitors from beyond our solar system. Its path through space tells the first part of the story. Unlike asteroids and comets born around the Sun, whose orbits loop endlessly under solar gravity, 3I Atlas follows a hyperbolic trajectory. This means it is not gravitationally bound. It did not originate here, and it will not stay. It entered the solar system from interstellar space, and after a brief passage, it will leave forever. This single detail makes it extraordinarily rare. Before 2017, humanity had never observed such an object. Then came Oumuamua, a discovery that challenged assumptions and sparked debate across the scientific community. In 2019, a second visitor appeared, 2I Borisov, unmistakably cometary, shedding gas and dust in ways astronomers could recognize. Now, 3I Atlas completes a small but remarkable trio. 3 confirmed interstellar objects, out of trillions drifting silently between stars, and each one has been different. This diversity alone is profound. It suggests that planetary systems elsewhere may produce a wide range of debris, icy, rocky, fragile, compact, shaped by environments far more extreme and varied than our own. Despite dramatic headlines and eye-catching thumbnails circulating online, there is no confrontation unfolding in space. No NASA probe is being challenged. No spacecraft is being approached or intercepted. Human technology observes interstellar objects from a distance, using telescopes that capture faint photons after journeys of millions or even billions of kilometers. Any interaction between 3I Atlas and humanity is happening in one direction only. We are watching. From Earth, from orbit, from instruments designed not to interfere, but to listen. So why all the intrigue? Because 3I Atlas is showing signs of activity. As it approaches the inner solar system, astronomers have detected subtle changes in brightness. These variations suggest outgassing, material warming, and sublimating from the object's surface as sunlight reaches layers that may not have been exposed for millions of years. This behavior is familiar. Comets do this all the time. But 3I Atlas does not behave exactly like a typical comet. Its activity appears faint and uneven. The brightness changes are not symmetrical. The gas and dust production, if present, is unusually delicate. Spectroscopic measurements hint that its chemical makeup may differ from comets formed near our Sun, potentially reflecting the conditions of an entirely different stellar nursery. This is not evidence of technology. It is evidence of diversity, and diversity is exactly what scientists hope to find. Every interstellar object is a natural experiment, one humanity did not design, cannot repeat, and is incredibly fortunate to observe. These objects carry within them records of environments that no telescope can directly see. The chemistry of distant protoplanetary disks, the violence of early planetary collisions, and the slow erosion caused by cosmic radiation over immense spans of time. Any discussion of interstellar visitors inevitably returns to Oumuamua. Detected in 2017, it stunned astronomers by accelerating away from the Sun without displaying a visible cometary tail. This unexpected behavior forced scientists to consider unfamiliar natural explanations, including hydrogen ice, nitrogen ice, and extreme shapes that could amplify non-gravitational forces. A small number of researchers suggested artificial possibilities. These ideas attracted enormous public attention. But speculation is not evidence, and with 3I Atlas, the scientific community is determined to proceed carefully. The focus is on data, not drama, on measurement, not mythology. Researchers are actively separating what is observed from what is merely imagined. This cautious approach is shared by physicists such as Michio Kaku, whose name is often associated with futuristic ideas. In reality, Kaku has consistently emphasized that interstellar objects are scientific opportunities, not threats. They are samples from elsewhere in the galaxy, fragments of other planetary systems delivered to us by chance. He has not claimed 3I Atlas is artificial. He has not claimed it is intelligent. He has not claimed it is confronting NASA. What he has expressed is astonishment, not at danger, but at discovery. Astonishment that humanity now possesses instruments capable of detecting and analyzing objects that began their journeys around other stars. From a physics standpoint, nothing about 3I Atlas requires intelligence to explain it. Its speed, while extreme, is exactly what one would expect from an object falling through the Sun's gravitational well from interstellar space. Its deviations from a simple gravitational path can be explained through known forces: solar radiation pressure, asymmetric outgassing, and gravitational interactions. There is no sign of thrust, no evidence of guidance, no deliberate course corrections. Nature, complex and subtle, is enough. Still, the public reaction remains unsettled, because uncertainty is uncomfortable. We are used to knowing where things come from. We can trace asteroids to families, comets to reservoirs like the Kuiper Belt or Oort cloud. 3 Atlas defies that comfort. Its origin lies somewhere beyond our maps, perhaps around a star we have cataloged, or perhaps one long gone. Its journey began before human civilization existed, before agriculture, before language, before memory. And now, briefly, it crosses our skies. That sense of cosmic transience, of something passing through without stopping, feels unsettling not because it is dangerous, but because it reminds us how small and temporary our vantage point really is. As 3I Atlas approaches its closest point to the Sun, telescopes across the world are focusing their attention on it. Among them is the James Webb Space Telescope, whose infrared instruments are uniquely suited to studying cold, distant objects. Webb is not searching for aliens, it is searching for chemistry. By analyzing infrared signatures, scientists can identify the composition of ices, the size of dust grains, the presence of organic molecules, and the way heat moves through the object's surface. Each measurement adds a piece to a much larger puzzle, one that seeks to understand how planetary systems form and evolve throughout the galaxy. Crucially, 3I Atlas poses no danger to Earth. Its trajectory does not intersect our planet. Its mass is insignificant on a planetary scale. Its passage occurs at a safe distance. There will be no impact, no tidal effects, no gravitational disturbances. The only thing it will leave behind is information, and that information matters. Interstellar objects are messengers. They carry the chemistry of distant systems. They encode the history of planetary collisions elsewhere. They allow scientists to test whether our solar system is typical or an outlier among billions. Each one is a question mark carved in ice and rock. 3 Atlas is not a warning. It is not a confrontation. It is not an intelligence. It is something quieter and far more profound. A reminder that our solar system is not closed, that material flows between stars, that the galaxy is dynamic, interconnected, and constantly reshaping itself through motion. One day, humanity may send probes beyond the sun. When we do, they too will become interstellar objects, drifting silently through unfamiliar systems, perhaps detected by distant civilizations that wonder where they came from. 3I Atlas is a preview of that future, seen in reverse. Something else's debris, drifting briefly through our home, and for a short moment we are allowed to study it. There is no confrontation in space today, only observation, only curiosity, only the quiet, patient work of science. And perhaps that reality is more astonishing than any imagined conflict. Because without intent, without awareness, without purpose, 3I Atlas has crossed the galaxy and found us watching.